Okay, so last session we talked about game theory and actions. In particular, I mentioned the motivation for actions and the fact that lots of big tech like Google, Facebook, Amazon, Microsoft, Bing, Apple, all of them, a very good portion of, their money actually comes out of the advertisement auctions. That's the reason that we are studying essentially auctions a lot. And of course, auctions are everywhere, not just in the big tech, in the, I don't know, for the oil, purchase of oil or like art or lots of other things that we discussed. So there are lots of application for that. And the important part of it. And especially when we talk about computational game theory, we decide essentially two things. What are the rules of the auctions and how can we compute it, the winner, etc., in a very efficient way? Because lots of these things, for example, in advertisement auction, you need to decide about the winner in like 20 to 120 milliseconds. And while you are getting essentially bits all over the place from the world. So it is very actually one of the most complicated computational issues that you have it just running the, say, display ad auctions or others. Good. So let's, we talk about two types of auctions before. So in particular, we talk about English auctions before, and we are talking about the other ones today. And we see that essentially this, as we discussed, there are two type of auctions. Lots of auctions that you are seeing either go to one of these. Either this is a kind of first price auction that the winner always, these are called efficient auctions. The winner always would be the person who has the highest. We try to essentially give it to the highest bid. And we hope that that is the highest valuation person. But the issue is that how much that person pays. If he pays his or her own bid, then it would be first price. If it pays the highest bid among all others, it would be second price. So these are the two types of auction that we are seeing over and over. And they may have a different name, but at the end, we go mainly into these two important auctions. There are some other auctions that we will talk more about them later, but these are like the two important. So now let's go to the first price sealed bid auctions. What are the examples? The examples are construction contracts. So here we are talking about the lowest bidder generally, but these are the same type of things. Real estate, you want to sell a house, or art treasures. The typical rule would be this: bidders write their bids for the object and the name of yes. So they write essentially their bids and their names on a slips of paper and deliver them to the auctioneer. This is like the sealed bid part. The auctioneer opens the bid and finds the highest bidder. And the highest bidder gets the object being sold for a price equal to his or her own bid. Winner's profit would be the bidder's value minus the price paid. As I mentioned, there are two things. It's your actual valuation versus the bid that you are putting. This bid is not necessarily your valuation. And indeed, if the bid is exactly equal to your valuation, you don't gain anything. The profit that you have out of this auction or your utility would be zero. Profit and utility is used the same way, essentially. You will see different things. Everyone else's profit would be zero because you don't pay anything, you don't get anything. Good. So let's a little bit, understand this one. Of course, there are lots of papers. Particular conference is for this type of thing, it would be good if you want to know more about the state of the art auctions, would be ACM EC, economics and computations. Before it was electronic commerce, it has been changed, the name still is the same abbreviation, economics and computations. That's a conference that you will go and you will find lots of state of the art, essentially, researches on, especially on all game theory and economics and computations. Lots of them about auctions. So you may go and read more about it. This is just some basic, and these are some of the type of simple analysis that you can see there. So we want to understand what should happen essentially in the first bid still price. So how you should bid essentially. That's the whole idea. That's the whole idea of, I mean, this one, and there are two parts of it. The person, the auctioneer who should run it. For example, Google, like it has Google Exchange. Lots of placement is done by Google and through Google Exchange. What is the role that Google should play to maximize his or her, like maximize its profit? While it is somehow fair for the people, at the same time, you may try to bid for some particular advertisement slot. This is something that a particular company is doing, that is Trade Desk. That is called demand side provider, DSP. So Trade Desk is a particular thing. There's another one, Math Media, but Trade Desk is essentially final one, is like the most important player, I will say here, that provides the strategies for you if you want to bid. So these are the auctioneer that runs it and you as a bidder. And these are lots of ideas that how you should bid essentially, especially when we are talking about the volumes of ads. It's not one bid or something like this. You are just defining some criteria, or they define some criteria. Based on that criteria, you are essentially bidding. And as I mentioned, this is always in the first price, there is a process called bid shading. Bid shading means that lots of these companies, they have auto bid shading. You will give your bids. They decide based on the information that they have about this particular auction, that how much they should shade your bid. Because if they don't shade your bid, then you put your bid, this is assuming that it is your valuation that you are giving them, then you don't get anything essentially. You always want to get some profit out of the auction. That's the whole idea. And so they shade it that you have still some chance, some reasonable chance to win the auction. And because it is lower than your actual bid, you actually, assuming that your bid is the valuation, then you actually have some profit. But here, let's understand the simpler game. So there are n bidders. Each bidder has a private valuation, VI. The private valuation, as I mentioned, bidder value, which is a private information. But a probability distribution for VI is a common knowledge, by the definition of common knowledge that we discussed. That let's say so that you can consider for different distribution. Let's say VI is like simply is a uniformly distributed over 0 to 100. It means that essentially gets this is the thing that if you consider this probability functions, essentially that would be the total value here between 0 to 100. That I think would be 1 over 100. So the total area, this is the probability distribution, thinks that what is the chance that you become 1 or anything essentially in between, 2 and so on and so forth. These are all equal. Say it was 1 over 100. This is a discrete version. You can consider continuous or discrete, not much differences here. But that's essentially the uniform distribution. It's a reasonable distribution. Not all the distribution are like that. And you may have, arbitrarily shaped distribution, something like this, for example. As long as essentially all of them are, these are the numbers that you will take, these are the probabilities that you are getting. This is the PDF essentially. And then as long as the sum of this is equal to 1, that is essentially probability distribution function. And you can have arbitrary things. And it is actually the people considering more generally, for example, as I mentioned, this ACM, EC things. We have considered, others have considered essentially this type of general distributions. And it is interesting. There are, you can consider Poisson or other normal distributions, that's other things that you can consider it. And it is actually a good exercise to do that. You can read also from the web And I think maybe ChatGPT also can help you there to find the other distribution. But here we are considering uniform distribution. So this is the uniform one that we are talking about. Let BI denote the bid of player I, and let high I denote the profit of player. So the question is that what is the Nash equilibrium bidding strategy for the players? We talk about, the other type of function that we discussed previous time, what are the Nash equilibrium, but let's see what would be the uh, essentially the Nash equilibrium in this case. And here we need to find the optimal bidding strategy. That's essentially the idea. Based on this information, what is yours? Let's consider n equal to 2. You have only 2 agents. Good. So we try to find essentially the optimal bidding strategies. We need to do some math. So let's BI again be the agent I's bid. Let pi I be the agent's I profit. And the VI is the actual valuation for this. This is the true valuations. So we know that if your bid is greater than your valuation, then your profit would be, as I mentioned, profit also, it is sometimes they use the utility. So if you bid more than the value that you have it, essentially, then your profit would be zero, like less than zero, actually. It can be less than equal to zero. Yeah, so you may think about there might be a house in the market and you may bid overpriced. That really doesn't mean that in this case your profit is negative, because in some sense you have a higher valuation for that house. That's the reason that you are bidding higher, even though the original price that they put it is lower than that. So it is not the case that this is essentially any reasonable auction, reasonable agent try to, don't bid more than its actual valuations or his or her actual valuation. So here, if so what is this auction given this? So if a BI is equal to, if I is essentially the maximum, this one. So in some sense, if I is equal to, we are using this one, arg max J BJ. So we discussed this one. Argmax means that that particular J that maximizes. So in that case, BI is the maximum. Then the profit would be, the pi I would be VI minus BI, which would be greater than or equal to 0. For anyone else, it would be 0 because you don't pay anything, you don't get anything. So the question is how much below your actual valuation you should bid. This is essentially the bid shading process. So the smaller BI, what is the good thing? The less likely that I will win the object because the others may win essentially. At the same time, you get more profit if you win it. So there is always this trade-off. This is exactly the issue with the bid shading. You can shade the bid a lot, but then you may not get it essentially. But you want to shade enough that still you have the essentially the highest expectation for the profit. That we will discuss here essentially. Good. So let's go for this one. So let's consider case of n equal to. Suppose your bidder valuation is V and your bid is B. This is for you. There are 2 agents. This is say I want to play versus other. Let X be the other bidder's value. Good. So I have V and B. The other person has X, and its shape is his or her own bit by a factor alpha. You don't know that. We don't know the value of X or alpha. Let's see what is your expected profit. Your expected profit would be this. The probability that your bid is higher than other person times V minus P, because that's the profit that you will get it. That's the expected profit. Plus, probability that your bid is lower times 0. In that case, you don't get anything. Let's compute this number. So if X is uniformly distributed over 0 to 100, then the probability distribution function, the PDF, as I drew in the previous page, it is called PDF, is f of X is equal to 1 over 100 for X between 0 to 100. So again, let's write this one. The probability that your bid is higher is that the probability that alpha X is less than B. Why alpha X? Because the alpha X is the X times alpha would be the actual bid that you are getting from the other person. And that is, of course, it is equal to X is less than beta over alpha. And this would be the integration. So you need to do the integration here. So here, what is this probability? Anytime that you want to find the probability of some range, here essentially is between X is between this is greater than 0 and this say, then you need to do the integration in the range. So in the integration, the range from 0 to essentially B over alpha, then this is the PDF function, f of X, d of X. F of X is 1 over 100. So if you do the integration, then essentially, because it's a uniform distribution, would be that would be essentially, it would be equal actually, time. So that would be beta over alpha. That is the range that you are doing it times the f of X, because it is uniform, it is 100, 1 over 100. So that would be essentially a simple thing that you will get. Now, so your expected profit then is equal to, so what was the expected probability? The probability that you will win, which will be this, time V minus P. So that is, if you want to maximize your expected profit and hence your valuation of money, then your maximum bid should be this. You try to maximize your expected profit. Here, essentially, this 100 and alpha, these are something, it is out of your hand. These are some constant that you don't know, but doesn't matter. So you only need to compute the part that it belongs to you, that is B times V minus P, which is max of BV minus P. So in general, if you want to do that, I mean, you can do essentially, you can just put these two equal. That's the thing that we have done it before. Or you can just take essentially the, you can differentiate essentially this, and then essentially from that, you can get the, put the 0 part in the differentiation. And then in that case, if you do that, when V minus 2B is equal to 0, as I mentioned, you can put also them equal, and then you will get the same thing there as well. Actually, you need to take the differentiation. That's the standard way to do that. And if you do that, you can get, this is a simple math that would be B equal to V over 2. So what's the meaning of that? It means that your bid should be half of the item, the actual value that this item worth. So if essentially you are going to some kind of advertisement auctions and you want to bid how much you should shape, if there are, you know that there are two people, then essentially you need to shape like something like half of the price. That's the one that maximizes your. However, this is for the case of n equal to 2. There are only 2 players. Let's see what will happen if there are more than 2 players in the game. So if there are more than 2 players, is then if there are more than two players, the only thing that will change. Okay. So here, the only thing that will change if there are more than two players, here you wanted to say that. So here you had this thing that we had these computations that the probability that your bid is higher than the other person. And that was essentially B over 100, B over 100 times alpha. So if you have n bidders, this will be generalized to B over 100 times alpha to the n minus 1, because you need to be higher than n minus 1 other person. Yeah.
But isn't alpha like...
Alpha is times that, essentially. This is like the...
But doesn't every bidder have
the bidders, I mean, yes, I mean, then in that case, I mean, that becomes more complicated. But I mean, you can just consider, for example, a simpler case that, I mean, they all of them say you don't know this alpha is some kind of average. But yeah, so then if you want to do it there, you can do a more complicated math. It's like this is just mainly give the intuition, but you're right, essentially. If they have a different alpha, then you need to consider different alpha, and then you can you need to have some assumption about it such that you can do that. And that is actually important. This is important. If you are a person and you know that, for example, this is known, for example, then some companies, some brands, they may bid higher. Nike, for example, is well known that is bidding high, actually, for example, for advertisement. All others may actually do it much smaller. So in that case, like sometimes the distribution changes, sometimes, as you mentioned, that you have a different alpha. Let's say here the simple thing that somehow you will, it's just, this is not the formal math, this is just some kind of intuition. That if they have said that consider alpha is like some kind of, they are doing all alpha bit shading, or alpha is some kind of average. This gives you some ideas, essentially, that what will happen if alpha is the same, for example, for all of them. Yeah. So in that case, I mean, assuming essentially the risk neutrality, you choose your bit such that you will maximize this, the same alpha. In that case, if you do that, your things would be like the actual bit that you need to do it. If it's the same alpha, it would be the actual valuations times n minus 1 over n. So essentially, if there were two, n minus 1 over n would be half. But as the number of, as n essentially increases, the b should be closer and closer to v. Essentially, increased competition drives bits closer to the actual valuation. Again, this is correct by this assumption that we are having currently considered the same alpha here. And also, we are assuming the valuations are essentially between like is a uniform. And these are somehow correlated. Note that at the end of the day, you get alpha x. Alpha is the bidder valuation, this bit shading factor, and x is the valuation. So anyhow, this distribution and this alpha, they have lots of interactions, because you can say that the alpha is 1, and then the distribution is a very general distribution. That doesn't matter. Does not change that much, essentially. Or essentially, you have a distribution of alpha x instead of distribution of x. But anyhow, so these are the maths that more this is the typical thing. For example, the people who are doing auctions. I mentioned this trade desk is one, but you may do auctions for other stuff. Like, for example, also a stock market is another one that the people actually, they are bidding and getting this one. They are hiring lots of mathematicians such that they can essentially compute some kinds of cases. And so that in these cases, if you are bidding this one, then we win. And these are the places that actually these companies, the Wall Street companies, they are, or traders, these are the ones that gain the money. They consider some cases, like a Renaissance is a famous one essentially. There are lots of other jump others. And all of this, the higher mathematician or the people with the strong math background, even the people like from physics and others, because you need to do lots of these kinds of calculations, integrations, and others. I say that if this is the assumption about the game, if you win, if you put this bit, then you maximize your profits. And that's the way that they actually gain things in the auctions. So lots of math uh, plus like theory essentially involved. Good. So that's, but this was a simple analysis. Again, you can read more about it in this ACMEC or the other sources. Good. So another one we want to talk about is the Dutch auction. So what is the so Dutch auction actually these are have been used flowers in Netherlands. I mean, you know, Netherlands actually is known for their good flowers. Uh, Fish market in England and Israel, or tobacco market, for example, in Canada. These are some of the like the typical things. I mean, they may change it by now, but these are some more historical things. What are the typical rules of Dutch auctions? So, and this actually you hear a lot about English auction and Dutch auction. These are like very famous ones essentially. There are others, but these are the most famous ones. So, auctioneer start with a high price. Auctioneer lowers the price gradually. So I want to say my fish essentially, I don't know, $1,000. And then you bring it. Okay, no one 1,000? No. What about 999? What about 990? You are repeating it until some buyer say, okay, it's mine. I get it like 420. Like very good fish. So the first buyer to shout mine gets the object at the price the auctioneer just called. Winner's profit would be essentially bidder's valuation minus uh, minus the price essentially that pays essentially or the bid that it. Everyone else essentially get the profit zero. So again, so you may, I mean, you may have this fish, I don't know, you may want it 500, but when that person says 500, you don't do that. You want to say, okay, I want to get it at the lower price because if you get 500, my profit will be zero. But of course, there is always this danger that somebody may come and get that fish essentially, I don't know, sooner from you. Dutch auction game theoretically is equivalent to first price, still bid auction. Why? Because the object goes to the highest bidder at the highest price. A bidder must choose a bid without knowing the bids of any other bidders. And the optimal bidding strategies are the same. So essentially, if there are two people in the market and these are the distributions are uniform, then in that case, actually, you may want to just do half of your price. That's essentially, at that time, you should stop. If you come too low, then the other person may say, I must. So in some sense, the Dodge auction and this one are game theoretic equivalent. At the same time, I mean, you may think about some differences. That's a good exercise to see whether they are completely the same or there are some. If you deep dive, then you see there might be some differences in this one versus that. But generally, that's essentially the things. They are equivalent. But again, you may consider the whole thing because this is some kind of the I mean, social event is happening, and that might be essentially a bit different. Like in practice, for example, this is a sealed bid, you just write it down and you give it, while you may get essentially more feedback in these auctions. because yes, it is a case that you don't know the actual bids of the other people, but you know that no one valuation was greater than this 990 or like close to that, maybe. These are some information that you may get more essential. And again, these are the assumptions, these are the modeling that you need to do. That the same thing that they have mentioned for the stock market. Essentially, you need to define the situation and say, what would be the situation? What are the constraints in the situation? In that case, what should I do? But for now, I think these are like, you can say they are equivalent. And good. Another one, which is, the other one that I already mentioned, but we want to talk a little bit more about it. This is the sealed bid second price options. So this is introduced by Vickrey in 1961. This is the generalization is called a VCG, essentially, to other people, Vickrey and to other people, they have used it. It has been used for stamp collectors auction, US Treasuries, long-term bonds, Airways auction in New Zealand, eBay and Amazon. This is actually the way that currently Amazon sponsored ads are running, or Google search ad is running. A display advertisement, as I mentioned, now it is go the first price actually. But search ads, those that if you search something that comes at Google, or if you see sponsored ads at Amazon, they are mainly based on this essentially second price. So there are always this kind of reserve price that I have mentioned, that they are adding it to get higher valuations. So what are the rules is that the bidders write their bids for the object and their names on a slip of paper and deliver them to the auctioneer. Again, now maybe they just essentially submit it on a website, essentially, or through an API they are doing. The auctioneer opens the bids and finds the highest bidder. It means that the auctioneer gets all the essentially requests through APIs and websites, essentially. The highest bidder gets the object being sold for a price equal to the second highest bid. And winner's profit would be the bidder valuation minus the price. Everyone else's profit would be zero. So what are the good things and what are the bad things here? So the equilibrium bidding strategy here, and essentially the equilibrium in the sense that, if the others change, you don't want to change. It is a weakly dominant strategy for you to bid your true value. This property is called truthfulness or strategic proof, things that we discussed. So this auction, if you essentially, this is important. It is a weakly dominant strategy to bid your true value. What's the meaning of that? It means that it is weakly dominant. It means that if you lie about your bids, you may not gain. You may not lose anything, but you don't gain. That's the meaning of the weakly dominant strategy that we discussed before, but that's essential. So, and this auction essentially is that this kind of second bid, sealed bid in some sense, was the assumption as well, but we talk more about the second price things. So the assumption is already sealed bid, because these people, all of them are individually essentially submit. They don't see the bid of each other. This is not correct if there is a collusion. If there's an internet, maybe 2-3 people know, you can still say that these are small players. But if lots of people know each other, then there's a big collusion. In that case, these are not correct. These are some assumptions that we are assuming. So assuming there is no collusion, they don't see their bids of each other, and they cannot coordinate on that one, then in that case, these auctions are a strategy proof or truthful. It means that you should say your true value. And that is essentially the most interesting thing about these auctions. As I mentioned, these are the ones that currently is used. The major ones is Google search ads, or like Amazon sponsored ads that you will see. If you go to Amazon, you will see some of them say sponsored ads. Those are running based on this second price. The good thing is that it's truthful. It means that the people don't need to shade their bid. While the display ad actually for a while first started at Google around 2000 or that time, essentially. It was actually first price. Then it went to second price, but then the people have played so much games there essentially by all this reserve price. And there are essentially lots of players. They decided that, okay, let's go to the first price. And you can, yes, this is the rule that this is the first price. The first price is not a truthful one. And that is obvious. Why is it the case? Because, like essentially, as we discussed, if in the first price, if you shade your bid, as we discussed here, like if you do half of your bid, that actually maximizes your profit. So you can, so you can actually get better profit or utility if you shade your bid. Here, if you shade your bid, that does not help you. You may not lose money, but it doesn't help you. Let's see the proof essentially for the this one. Why is it the case? So we need to essentially what is the general idea, the intuition of the proof is that if you overbid, say over than your actual valuation. So I want to say here the bidder's valuation, essentially this is the valuation and this is the bid. So the bid should be equal to your value. And that's a very good thing because then the people don't need to essentially worry about it. But as I mentioned, the bad thing is that the auctioneer in some sense is losing money. So for example, if this is the house and someone wants this house, I don't know, for 1 million, all other they want it essentially, say 500 or say 800,000. So in that case, if you want to run it actually the second price, so there is one person who wanted 1 million and can pay you 1 million, but say, okay, I will give it to you 1 million, but I only charge you 800,000. That never happens essentially in real estate. But the issue is that auctioneer, actually, that person, the seller in this case, that person loses money. And that's the whole idea of these other ideas that I discussed, that they are adding a reserve price. It says, okay, if my price is less than 1 million, I don't give it essentially. So in that case, it means that, or if it is above, since I will charge you at least 1 million. So in that case, essentially, I'm running a combination of Vickrey. And so so essentially that would be the auction, that if there is a person which is above 1 million, I will give the maximum of second highest bid, and 1 million. If it is below that, I don't sell it because I know the value of my house. But this is the typical thing. If the reserve price in combination of second price is used in lots of industry, lots of these cases that I have mentioned, they are using lots of reserve prices. And this reserve price, the issue is that they are computing it from the history and then essentially makes it non-truthful, but that's a different, more deeper thing that I don't want to go through that. Let's go back to here and see that why is it the case. So I want to say overbidding or underbidding. So if your bid is greater than V or less than V, that does not help you. Okay, so let's write the formulation. Let V be your valuation of the object. Here, essentially, we are using capital V. Let X be the highest bid made by everyone else. And let SV be the strategy of bidding V. So pi V would be your profit when you are using SV. So a strategy would be SV means this is because your bid is actually your strategy. So that's based on, that would be S of V means that you are bidding V, and pi V would be your profit. SB would be the strategy if you bid something B which is not equal to. And pi B would be the profit when you are using essentially. So say here we are just doing essentially just capital V, the actual valuation, and B is the bid that you are doing, V is the actual valuation. We want to say if it is not equal, you don't gain anything. Okay. Now, there are three important things that we are talking about, three important factors. This B, V, and X. What was X again? The highest bid made by anyone else. There might be lots of people, the highest bid among others. So then we only need to consider this B, V, and X. The order of them, there are only 6 factorial. There are only 3 factorial things because there are 3 things, and like who is larger than who, that's essentially that this size or this. You can say equality, but that doesn't change anything, essentially. So you can add some of this equality, but that doesn't change that much. Okay, so there are only these 6 cases that you need to consider, and you can go one by one. I will go to some of them, then you can check the others. So if X is greater than B is greater than V, so it means that everyone else's, the highest bid is larger than your bid. So in that case, you don't get the commodity either way. So if you put it B or V, because the price of, there is one person higher than your bid anyhow, then you don't get it. In this case, both cases would be 0. Yes, you can lie, but you don't gain anything. Now say your bid is greater than X and X is greater than V. Again, these are all 3 factorials that happens with this. We have these 3 things, and if you want to put them in an order, there are 3 factorials. In object, there are n factorial orders. So in this case, actually, if you put B greater than X, then you are just losing money because your valuation is V. Yes, you win it, but you win at a loss, essentially. So you will be, in some sense, I mean, the person who is doing that would be a loser, actually. Yes, you can get it, but I mean, that there is not that much worth for that. So in that case, you actually lose if you do bit higher than X. But if you just do your valuation, you don't get it, but then your valuation would be 0 as well. So essentially, you don't pay anything. So this would be essentially, so in that case, it's actually overbidding, you lose money. In the previous case, you didn't lose money, but here you lose money. Now let's consider this one. So what about B is greater than V greater than X? So here, in this case, this bid, so your bid is greater than V and is greater than everyone else's. So in this case, either you will do B or V, you will get the object, so you will be the winner. How much you will pay, it is independent of your bid. That is the most important thing, essentially, about truthful actions, that the value that you will get charged, it is independent of your bid. That's the, so an action would be truthful if the value that you will pay, it is independent of your bid. It can be like the maximum of everyone else, but it is independent of my own bid. So in this case, you will anyhow pay X. So your actual things in both of case, so even though you beat the value, the how much is the valuation is V, how much you will pay X, which is greater than 0. So it doesn't matter. In both cases, you get the same thing, even though your bid was greater than B, because this is independent of your bid. What about this one? If it is the case that, so this is the other case. So this is the, so it was the case. What about that? X is less than B, less than valuation. So here essentially, these are both the same cases. Here you will overbid. Here you underbid. If you do underbid, again, no matter what happens, you pay X rather than your bid. So if you put V or B, there is no difference. And in both cases, you get V minus X. Now, what about if you underbid even less than X? In this case, your then you don't get it because someone else is getting it. So in that case, pi of B would be 0. So if you do it actual valuations, you will get V minus X, which is greater than R. And last but not least, this case, that B is less than V less than X, essentially. So this is actually, this is very similar to this case. So in this case, because X is greater than, you will essentially underbid a lot your valuation, and the valuation is still less than the highest among other. In this case, you don't get the community either way. So in that case, pi V and phi b equal to 0. So as you see in all cases, if you lie, either you lose or you don't gain anything. That's the meaning of truthfulness about this fiction. And if you consider this case, it is actually a very important one. This is like the first time that I heard it was in some conference, I think Fox 2001. At that time, I mean, I think there was no such kind of case analysis. But when you do the case analysis, then you will see why this happens. Good. But as I mentioned, this argument does not work for the first price, because in first price, as we talked, if you do the bit shade, in particular, if there are two people, you do it half of the price, that's actually the one that maximizes your profit. So here, I mean, we talk about English auction essentially that we discussed previous time. Here, and if you remember in the English auction, the price is going down, up essentially. So you will say, okay, this is the person, the highest one. Anyone higher, then if there's another one higher, you will go a little bit. Generally, you need to go a little bit up essentially. You cannot just be epsilon. That epsilon should be at least, I don't know, $10 or something, dependent to the auction. So this sealed bid second price auction are nearly equivalent to English auctions. Again, not completely the same, because there, for example, you need to go at least, I don't know, $10 up. But here, maybe your actual valuation is just $1 up or something like this. There are some other differences. But in that sense, they are the same, that the object goes to the highest bidder. And price is close to the second both of them object goes to the highest bidder, and the price is close to the second highest bid, because there, I mean, if there is no one else, that you just go a little bit there and no one wants more. Maybe your actual valuation is much higher, but because there is no other competition, you will win it in English auction. So in that sense, these are the same action. Good. So let me go to this one. Good. So I want to do in the class two type of auctions, and then I want to finish with some real world things about this. So let's do an English auction first, and then I will run a modified English auction. So in the English auction that we are doing, I will auction a $1 bill in an English auction. It will be sold to the highest bidder who pays, who must pay the amount of his or her bid. So I will just like run it on the class. And there is no collusion, say. And the minimum increment for a new bid is 10 cents. So that's the first one. The second one is the modified English auction that I'm doing exactly like this, but this is the catch. So the bill will be sold to the highest bidder who must pay the amount of it. The second highest bidder must also pay his or her bid, but get nothing. There is, do not collude, and the minimum increment for the new bid is 10 cents. So the main or the only difference essentially is this new rule that I have. This is the additional rule. The second highest bid must pay his or her bid, but gets nothing. That's the difference between these two actions. Okay, so and then I will say something more about the real world here. So good. Okay, so let me just mention the summarization of this one that we've done it in the class for this one. Good. So when we done it with the English auction, we ran it essentially $5 because I didn't have $1 bill. So we ran it with $5 and we said that it should be at least 50 cents increase. The person who won it got $4.75. And we discussed that essentially these are the rules of the auction, because you need to go 70, at least 50 cents up. I mean, he talked about it, and this is the best strategy. As I mentioned, in short, the real life is like this kind of auctions or like these games, that there are some rules. As long as you don't violate these rules, you can do the best thing that you can do. If I mean you believe in some religion or something, these are also some additional rules that you can do. As long as you don't violate it, you can actually do the best you can do. Yes.
I just realized for the one you just for the modified one, the best strategy is for the first person to get 451 because that way they get the $5 for 40 and giving 49 cents and nobody
Yeah, let's think more about it. It's not that simple, this one, actually. But that's actually interesting exercise. So the first one was, as I mentioned, 475 for $5 bill. The second one was more interesting. This one, the final thing, this again was for a $5 bill. So this is the $5 bill. And the two highest was, I think, $5.01.
Yes.
$5.01. And the second one was 451. So these are the two highest people. And as you see, essentially, and it stopped essentially here. And then they both decided to give five and like this one, essentially almost 950 or something like this for a $5. And you see that here the auctioneer actually got money. This is the important things. These are the things that actually the auctions. This actually we had some article I think on that. I think we may have put it in archive as well. I need to recheck. But this is the idea. If the auction, you can easily put lotteries and lots of Ponzi schemes in terms of auctions. These are seem very reasonable auctions. But what is the idea of these Ponzi schemes and others? That essentially, or lotteries, the main idea is that the auctioneer gets lots of money. This is the, for example, the rule that lottery generally is run by some government, except some areas essentially. But in US, lottery is run by some government. Why? Because they said, okay, because there is some money involved, probably the auctioneer gets the actual money or the real money, but that's the government. Anyhow, you can consider some, I think, tax that people are calling. Uh, but anyhow, so that's for the lottery. So, and this is the real world. I just want to give one example, but it should be very important. All these kind of Ponzi schemes are the same as well. So, in some sense, the person who gets the money is the one that runs the auction, essentially. Good. So, and this is actually a very valid question. Like, you can even ask about, like, I don't know, Google, Amazon, Facebook, all of them are running. Whether there is some kind of Ponzi scheme there or not, essentially. That's an interesting question. And this is the thing that, I mean, these kind of regulators, they should do it, and they are doing, but it's a complicated problem. It's hard to see whether this is actual, I mean, reasonable auction or actually some kind of lottery or this kind of Ponzi scheme. This is a real life analogy that I want to mention. This is actually interesting. So this is like this was this the name of this website was Suopo. Used to be a website that auctioned items. It was I think now is not working. You can search about it. Uh, Unlike ordinary auctions, this is very similar this idea of modified auction. Unlike ordinary auctions in which bid cost nothing, Suopo, so they didn't have the second person should pay. That was like very obviously. You can actually have, I don't know, start up this, but they may come and essentially uh, put you in jail if your website become famous. Here they change some other part of it. So they said no, the second price. So this is all pay auctions or second bidder pay auction. It was not like that. This is maybe too obvious. They change a little bit some other part. Here, to put a bid, you need to pay something. Again, that's a reasonable thing. You want to put a bid, pay something. So Solver required bidders to pay 60 cents per bid for each of your bids. Now what happened? So bidders didn't pick the price. Also, that was the other thing. So there was, if you want to put a bid, you need to put 60 cents. On top of that, there was this thickness. Bidders didn't pick the price of the bid. Swapo would increment the last offer by a fixed amount, say a penny, 6 cents, or 12 cents. And that was determined before the start of the auction. So you will come, if you want to hire, you will pay 60 cents, the price go 10 cents up. Every time someone placed a bid, the auction got extended by 20 seconds. So this is the example. You can go and actually search there in the slide. But Swappa, this is one example. Swappa auctioned an ounce of gold worth at that time, say 1100. I don't know what is the current price, 1400, no, 1800, something like this. The selling price was 2 or 3. Increment was 1 cent. It means that there were these times, because 1 cent is 20,000 bits essentially. They got 60 cents for each of them. So the total that they got it in terms of revenue was 12,000. Then, so Swappa 12,000 paid essentially 1,100 for the cost of the bid. The person that who got it actually was something like 2 or 3. That person got it. And they netted essentially this 12,000 minus 1,100, essentially 11,000 out of this. And of course, the winner's total price was the selling price plus the price of his or her bids. I don't know if this was, I think that this is the things. I heard that the winner probably paid a total of about 600. So even the winner was not really winner, paid 200, but it can be the case that, okay, the winner is like various things and just paid 60 cents and got the last thing. This is exactly you're doing lottery, essentially. You see, this is exactly the lottery that you are running. So if you are the last guy, and after that, no one increases, that you got it with a very good price. So you are running a lottery out of an auction. And it is not that easy to understand what's the meaning of a good auction versus bad auction versus lottery. This is the thing that actually math is coming and the rules are coming, and like you need to go, if you want to sue this company, you need to go in front of a judge and say that there's a problem for this one, this is lottery. You need to convince the judge. He or she may not know essentially game theory, that this is essentially some kind of Ponzi scheme or some lottery or something that they are doing. It's not that easy. So, and it can be more complicated. You can add more rules, you can change other stuff and essentially make it complicated. So it is really is then the math becomes more important and lots of analysis. You need to do it in front of a judge essentially to do that. Anyhow, that was the real life analysis for the auction. So you need to really think deeply about auctions and understand them. And that's exactly the thing that, as I mentioned, auctions, if you know game theory, if you know computer science, computational issue, this is a gold essentially. The people think about machine learning. Machine learning is important, but the auctions are more important because all these $1 trillion companies, they are all talking about auctions. They get the money out of auctions. And if you can help them to get more money out of it, better things, then I feel they can hire you and they pay you a good amount. Great. And then we will continue next time.